Hi guys, welcome back to the channel. So today we are going to be discussing about the second question, which is a weekly contest question. So apply the operations to make the sum of array greater than or equal to k. So we are given a positive integer k, and then initially you have an array of nums equal to 1, and then we can choose any of the following operation on array. Can be number of times, possibly 0. Return the minimum number of operations required to make the sum of the elements of the final array greater than or equal to k. So suppose let's take this particular example where we have k equal to 11. That means we are going to make this particular array with the sum value equal to 11 or more than 11. Suppose I have 1 initially. So after taking the steps like 1 1 1 1 till 10 11 times, that means 1 plus 10 times we are taking operations. So initially we have 1 which is already present, and then we are going to make 10 such operations, and then we are going to get the particular answer as 1. Suppose let's say we, instead of doing this particular operation, instead of increasing this duplicating the array, can we do this particular, can we increase to 2 and then make it as 2 2 2 and then 2. So this is going to be my 10, and then this is going to be my 12. And then if I consider 3, then it is going to be 3 and then 3 and then 3, and then again it is going to be 9 9 plus 3. So 9 plus 3 is going to be 12. Yeah. And then again I am going to consider 4 and then 4. So this is going to be my 12. Suppose let's say I take 5. Then it is going to be 5 5 and then again 5, and then so on. So this is going to be, out of all these things, what are the operations which are taken. For this I'm going to increase the increase to 2 for that one operation, and then I'm going to have 3 plus 3, which is going to be 5 times. So this is going to be 6 answer. For this it is going to be 3 plus 2, which is going to be 5, and then for this it is going to be 2 operations, and then to increment it is going to be 3. For this it is going to be 5. Yeah. For this I'm going to take 3 times and then to increment 2 times. Yeah, out of all these particular possibilities, we are going to consider whichever takes the minimum operation. So suppose I want to take, if I take this particular 1, then it is going to have 11 times. So this is going to have 10 operations. So this will not be optimal. So this is also will not be optimal. So 5 is going to be my optimal solution. So I am going to return this particular 5. So how we can solve this? Suppose I'll take the solution. Suppose if k equal to 1, that means this is the answer which we want, which is num_psi. And then let's say if I take 1, if I make every element which is present in this particular array as 1, then my answer is going to be I, and then after that I am going to consider each element. Suppose let's say I have the remainder, then I am going to consider increment of this. Suppose let's say I have this particular element which is 2, I have this particular element which is 11. So for this I am going to consider how many times this particular I plus 1 should be present. So that we are going to get via k by I plus 1. Out of this I am going to reduce 1. Why? Because this is already present. One particular element already present, so we do not need to do again this particular operation. So this operation is going to be how many times we need to increment this particular value. Suppose if I take I equal to 1, that means I am going to increment the value which is present in the num_psi to 1. Suppose if I take it as 2, then I am going to increment by 2. That means 1 plus 2 is going to be 3. So for this particular 3, I am going to take only 2 operations to increment. And then let's say suppose if I have some remainder after dividing this particular element, then I am going to take one more time this particular array. So that operation is going to be incremented. And then suppose let's say it contains these many times of elements which are present. So out of these operations, suppose if I divide the 11 by 1, which is going to be 11. So 11 is 11 or the 11 is not the number of operations. Why? Because we already have 1 which is present in the array. So we need to do only 10 operations. So that's why I am going to consider k by I plus 1 minus 1, and then out of all the answers we are going to consider the minimum of the answer, and then we are going to return the answer. Yeah, that's all for this video. And then if we come to the time and space complexity, the time complexity is going to be big O of k, and then space complexity is going to be big O of n. Yeah, that's all for this video. Thanks for watching the video.